How are you? So today we are going to start new chapter, chapter 6, that is your gravitation. So the chapter is very much interesting. Gravitation is one such chapter. I'd like to tell you that this is endless one. So interesting chapter, and the depth of the chapter. Let us go to the depth of every topic of this chapter. If you are interested in astrophysics, so little bit of this you will get here in this chapter. I am telling you one thing, if I am talking about the importance, I am here in front of the camera, I am taking this online class, and you are here going through these online classes, or the system, whatever the work, whatever may be, so nicely organizing is only because of gravitational force, only because of gravitation. You are thinking like that, I am taking the classes, then how it is related with gravitation or gravitational force? Yes, this universe is bounded, and so nicely bounded only because of gravitational force. In absence of gravitational force, if suddenly this gravitational force disappears, সিস্টেমটা আর থাকবে না, এই সিস্টেম আর এরকম কাজ করবে না। So all the material body of this universe are bounded under a force which is known as the gravitational force. So let us first of all try to understand what is gravitation and gravity. Chapter is your gravitation. So gravitation and gravity. Let us try to understand what is gravitation and what is gravity. Every material body of this universe attracting each other with a certain force which is known as gravitational force or gravitation. Force of attraction between any two material bodies of this universe. Force between this marker and this camera. The force of attraction between these two is also gravitational force or gravitation. And out of these two, if one is your earth, then it is known as gravity. Force of attraction between this marker and earth is known as gravity. Force of attraction between me and earth is known as gravity. But the force of attraction between me and marker is known as gravitation. So the force of attraction between any two material bodies of this universe is known as gravitation, and out of these two, if one is your earth, then a special name is there known as gravity. It is also gravitational force, but it is special name is there and is known as gravity. Force of attraction between moon and earth is gravity. Force of attraction between moon and Jupiter force of attraction between moon and sun. This is gravitation. So, this gravitational force is very weak force, but the range is infinite, its range is infinite. That is, sometimes we think that the gravitational field of the earth is limited within a certain range, but actually the gravitational field of the earth theoretically can extend up to infinity. My field you can extend up to infinity. I can attract any object of this universe, whatever the distance between them, up to infinity. There is force of attraction. But as the force is weak, so because of the disturbance of the other, practically it would not happen. Practically range of the field is limited within a certain region, but theoretically the gravitational force of any object may extend up to infinity. So, this is your gravitation and gravity. Now, we see, as I am telling you that every body of this universe attracting each other with a certain force. So, obviously a question will come, what is the magnitude of force, what is the direction of force, or on what factors this force depends. So many questions will come. Right now, as force of attraction is there, what is the nature of force, what is the magnitude of force, what are the, on what factors this force depends, right now. So, let us discuss this. A law is there, you are very much familiar with that law, and is known as Newton's law of universal gravitation. Newton's law of universal gravitation. Newton's law of universal gravitation. According to Newton's law of universal gravitation, every material body of this universe attracting every other material bodies with a force, and that force is directly proportional to the product of their masses and inversely proportional to the square of their separation. You see, I have two masses, m1 and m2. Separated by a distance r. Separated by a distance r. Let us consider two masses m1 and m2. And r is the distance between their centers. Then according to Newton's law of gravitation, there is a force of attraction between these two bodies, and the magnitude of this force is directly proportional to the product of their masses and inversely proportional to their square of their separation, square of the distance between their centers. Combining A proportional to m1 m2 by r square. Combining 1 and 2, F proportional to m1 m2 divided by r square, or F is equal to G m1 m2 by r square, where G is a constant of proportionality known as universal gravitational constant, and its value is 6.67 into 10 to the power minus 11 Newton meter square kg inverse 2. G is a constant of proportionality and its value is constant. Its value at every medium, whatever the medium, everywhere, universal constant, everywhere the value is same. Its value is obtained in laboratory considering known mass, known separation and force. We will get the value like that 6.67 into 10 to the power minus 11. Newton meter square kg inverse 2 is the unit of G. Well, let us see the unit as a unit and dimensional formula of G. F is equal to G m1 m2 by r square, or G is equal to F r square m1 m2. F is Newton, r is the separate, F SI unit of force is Newton, SI unit of r means separation, meter square, mass kg, another mass kg, right, or it is nothing but Newton meter square kg inverse 2. So therefore SI unit of G is Newton meter square kg inverse 2. Now see the dimensional formula. G is equal to dimensional formula of force is m1 L1 T minus 2, r is length L2 by mass m, another mass m, m1 L1 T minus 2 L2 m. So it is nothing but m1 here it is m minus 1, see m2 and here m1 means m minus 1 L1 L2 L3 T minus 2. This is the dimensional formula of universal gravitational constant m minus 1 L3 T minus 2. So SI unit and dimensional formula of G. Understand na? Okay. Now let us see some notes on this gravitational force. Note 1. Note 1. Gravitational force is always attractive in nature. There is force of attraction between the two material bodies. You see, electrostatic force may be attractive or repulsive depending upon the nature of the charge. But gravitational force is always attractive in nature. Always attractive in nature, right? Number 2. The gravitational force between two objects always act along the line joining the center of the two masses, direction of force. the gravitational force always act along the line joining the center of the two masses. Hence, gravitational force is a central force. Central forces are those forces which always act along the line joining the center of the two bodies. Electrostatic force is also a central force. Gravitational force is also a central force. So, Newton's law of gravitation, the full statement would be like that. According to Newton's law of gravitation, every material body of this universe attracts every other bodies with a force whose magnitude is directly proportional to the product of their masses and inversely proportional to the square of their separation, and the force always act along the line joining the center of the two masses. So, gravitational force is a central force. Means it would not apply the force like that, it would not apply the force on it like that, no, they always act along the line joining the center of the two masses. So, gravitational force is a central force. Number 3, gravitational force is a conservative force. The work done against the gravitational force is independent of path. It only depends upon the initial and final point, and so the work done over a closed path against the gravitational force is always 0. So, gravitational force is a conservative force, right, which is independent of path followed, only depends upon the initial and final point. Now, another thing is there, you see, gravitational force, this law of universal gravitation, it fails whenever the separation between the two bodies is less than 10 to the power minus 9 meter. That is in the range of intermolecular separation. Intermolecular separation, 10 to the power minus 9 এর থেকে যদি কম separation হয় দুইটা বডিজের মধ্যে, then the Newton's law of gravitation এইখানে fail হয়ে যাবে, fails to explain, right. The force of gravitation between two bodies whenever their separation is less than 10 to the power minus 9, there this Newton's law of gravitation will not be valid or applied. Understand now? So, these are the points you have to remember for gravitational force. And another thing is that the gravitational force between two bodies, between two material bodies, is independent of the nature of the medium, because the gravitational force between two bodies F is equal to G m1 m2 divided by r square. If two bodies are same, means their mass is same, their separation same, then everywhere their gravitational force between them is also same. See, I have two bodies, here 1 meter separation. If we keep them in water, or if we keep them on the surface of moon or on the surface of Mars, everywhere the force between these two will remain same, provided their separation and mass will remain same. If separation and mass will remain same, the gravitational force between these two here or in water or in any other medium every medium, the gravitational force between them will remain same, provided their separation and mass will remain same, whatever the medium, because gravitational force is independent of the nature of the medium, because the value of G is constant, universal gravitational constant. Understand now? So, here you see I have only written the scalar form. So, let us go to the gravitation, vector form of Newton's law of gravitation. Vector form of Newton's law of universal gravitation. Vector form of Newton's law of universal gravitation. See, let us consider 2 point masses. Let us consider 2 point masses m1 and m2. Let us consider 2 point masses m1 and m2 having position vectors r1 vector and r2 vector with respect to the reference point O. Now, let us consider 2 point masses m1 and m2 located at points A and B having position vectors r1 vector and r2 vector with respect to the reference point O. I repeat it again. Let us consider 2 point masses m1 and m2 located at points A and B having position vectors r1 vector and r2 vector with respect to the reference point O. Then obviously the displacement vector is r12 vector is equal to r2 minus r1, right. Now we see there is a force of attraction on m1 due to m2. At the same time, there is a force of attraction on m2 due to m1. There is a force of attraction on m1 due to m2, force on 1 due to 2. At the same time, there is a force of attraction on m2 due to m1. There is a force of attraction on m2 due to m1. So, the direction of a vector is given by the unit vector. So, here the unit vector is r12 cap, this unit vector is r2 cap. r12 cap is the unit vector pointing from 1 to 2, m1 to m2, and r21 is the unit vector pointing from 2 to 1, from B to A. r12 cap is the unit vector acting or showing the direction from A to B, from 1 to 2, and r21 is the unit vector pointing from 2 to 1. Now, you know r12 and r21 both are unit vector, magnitude is same, but direction is opposite. So, r12 cap is equal to minus r21 cap, right. Now, we see the gravitational force on m1 due to m2 is, the gravitational force on m1 due to m2 is, the gravitational force on m1 due to m2 is f12 vector is equal to g m1 m2 divided by r12 square r12 cap. See, f12 vector means considering the direction, let us first of all write the magnitude. F12 is equal to G m1 m2 divided by r square, separation r12 square. Now, as here vector sign means direction, I have to consider the direction of f12. The direction of f12 is given by the unit vector r12 cap, or you may write it like that, f12 cap is equal to minus G m1 m2 divided by r12 square r21 cap. r12 vector is equal to minus r21, so r12 cap is equal to minus r21 cap, minus is taken here. Understand na? The gravitational force on m2 due to m1 is, the gravitational force on mass m2 due to m1 is f21 vector is equal to G m1 m2 divided by r21 square r21 cap. Gravitational force on m2 due to m1 is f21 vector is equal to G m1 m2 divided by r21 cap square r21 cap. Try to understand. If I am not writing the vector sign, then it would be like that, f21 is equal to G m1 m2 divided by r21 is the separation square, and if I am giving the direction vector sign, then I have to write the direction of this vector r21 is showing this direction r21 cap, or f21 is equal to minus G m1 m2 divided by r21 square r12 cap, because r21 is equal to minus r12 cap. This is nothing but vector form of Newton's law of universal gravitation. Now, we see from equation 1, f12 vector is equal to minus G m1 m2 divided by r12 square r21 cap, minus G m1 m2 divided by r12 square r21 cap, or f12 vector is equal to minus G m1 m2 divided by, you see r12 vector is not equal to r21 vector. r12 vector is not equal to r21 vector, but because r12 and r12 vector r2 minus r1 and r21 is r1 minus r2, but r12 square is equal to r21 square, r12 square is equal to r21 square, means you see r12 square you may write r21 square, because r12 square will remain again the same value, 3 minus 2 and 2 minus 3 is not same, but 3 minus 2 square and 2 minus 3 square will remain same. So, r12 square is nothing but r21 square r21 cap, or f12 minus gm1 m2 divided by r21 square, gm1 m2 divided by r21 square r21 cap is nothing but f21. That is f12 vector is equal to minus f21 vector. If f12 is considered as action, then f21 is considered as reaction, Newton's third law of motion. So, this shows that the importance of this vector form, importance of vector form. See, number 1, since f12 is equal to minus f21, The two forces are equal in magnitude, opposite in nature, acting along the line joining the center of the two masses, and hence gravitational force is a central force. Gravitational force is a central force because they are acting along the line joining the center of the two masses. And number 2, you see F12 vector plus F21 vector is equal to 0, means net force is 0, means total work done over the closed path is 0, means work done is independent of path, means gravitational force is a conservative force. Total work done over the closed path is 0. So, gravitational force is a conservative force. So, this is the importance of vectored form. Understand now? Understand? Okay. Now, let us go to the next topic. Acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity. What is acceleration? Already we know. Rate of change of velocity. Change in velocity in a given time. So, this is acceleration. And for acceleration, there should be an external force. In absence of any kind of external force, a net force, there is no acceleration. Already we know from Newton's first law of motion. So, acceleration is because of the force. As we are here on the surface of the earth or near the surface of the earth, so there is a force on us and it is known as gravity, and because of this gravity there is an acceleration on us, and which is your acceleration due to gravity. Acceleration due to gravity, name indicates that acceleration due to the gravitational force. Because of this gravitational force, there is an acceleration on us. How this acceleration? You see, when any body on the surface of the earth or near the surface of the earth, obviously there is a gravitational force of attraction towards the center of the earth, which is generally or commonly known as vertically downward force, which sometimes we call the weight of us, downward force. That force is towards the center of the earth. We call it weight. Now, because of this force, there is an acceleration on us. If we throw any body away from the surface of the earth, its velocity decreases at the rate 9.8 meter per second in every second. When any object moving in upward direction like that, its velocity decreases as it goes upward, and at the top of its motion its velocity becomes 0. I am throwing an object with certain velocity, and after that there is a constant force, there is a force due to gravitation, and because of this force toward the center of the earth, there is a retardation, there is a decrease in velocity at the rate 9.8 meter per second, and as the velocity decreases at every second at certain time, the velocity becomes 0 at the top of the motion of the body. So, whenever any object moving upward direction, its velocity decreases at the rate 9.8 meter per second in every second. Now come to the case whenever the object is moving in downward direction. Whenever the object is moving in downward direction, its velocity increases at the rate 9.8 meter per second in every second until it hits the ground surface of the earth. So, as the body is moving away from the surface of the earth, its velocity decreases. As the body is moving toward the surface of the earth, its velocity increases. That is, there is a constant, there is a change in velocity, and which we call the, and it is because of this change in velocity is because of the gravity force. So, it is known as acceleration due to gravity. Acceleration due to gravity. Whether the body is moving for upward or downward, there is an acceleration, and that acceleration is 9.8 meter per second square. Direction is vertically downward direction, oftenly call it, but actually direction is towards the center of the earth, which we call the vertically downward direction. So, it is generally denoted by small g. Small g is the acceleration due to gravity, and whose value on or near the surface of the earth is 9.8 meter per second square. We will see the variation of g with height, with altitude, with rotation, with shape. We will discuss later, but roughly on or near the surface of the earth, its value is 9.8 meter per second square. So, it is known as acceleration due to gravity because of the gravitational force, because of the force due to the earth, or because of the force of attraction due to earth. Whatever the acceleration come into play, that acceleration is known as acceleration due to gravity. Understand now? So, this is your small g. Its value will change. Its value is not constant. With altitude, with depth, with rotation, with shape of earth, its value will change, but capital G, its value will remain same. Its value is constant. It is an universal gravitational constant. Understand now? Okay. Chalo. Let us see the expression for acceleration due to gravity. Expression for acceleration due to gravity. Expression for acceleration due to gravity. Let us consider Earth to be a sphere. Let us consider Earth to be a sphere of radius RE and mass ME. So, let us consider Earth to be a sphere of radius RE and mass AB centered at O, right. Now, consider any small mass on the surface of the earth, a small object of mass small m on the surface of the earth. So, the gravitational force of attraction between M and ME is, gravitational force of attraction between this small object and earth is F is equal to G M ME by RE square, right now. Now, you see force on the object of mass small m is, downward force on the object is Fd is equal to mg. Downward force on it is mg. Downward force on the object is Fd is equal to mg. Now, why this downward force? Because of the force of attraction due to the earth. Now, this downward force is because of the gravitational force Fg. Downward force is because of the gravitational force due to the earth, or mg is equal to g m me divided by r square, or g is equal to g me by r square. There is this acceleration due to gravity of earth depends upon the mass of earth, the radius of earth. If the radius of earth shrinks, if the radius of earth decreases, then acceleration due to gravity increases. If the radius increases, acceleration due to gravity decreases. Acceleration due to gravity also depends upon the mass of the earth. And this concept of acceleration due to gravity you can apply for any other planet also. For any other planet, Gp is equal to Gmp divided by Rp square. That is mass of that planet and radius of that planet. Or any other celestial object, not only planet, any other celestial objects, you can obtain the acceleration due to gravity of moon, right? Or you can compare it by using this relation. So, the acceleration due to gravity, you see, you can change the acceleration due to gravity of earth, if it is possible for you to change the mass of earth or to change the radius. Yeah, radius, yeah, distance between these two. If it is going, this object is going close to the center of the earth, its acceleration decreases, we will discuss later. If it is going away from the center of the surface of the earth, then also its acceleration due to gravity decreases. We will discuss the variation of acceleration due to gravity later. Now, here you can also obtain the mass of the earth. See, mass of earth, mass of earth, m is equal to gr square by capital G, gr square by capital G. Small g is 9.8, r is 6.37 into 10 to the power 6 whole square. Radius of the earth is 6.37 into 10 to the power 6 meter. In some book it is written like that, 6.37 into 10 to the power 7 kilometer, 10 to the power 3, 10 to the power 6, so 10 to the power 3 and 10 to the power 3 for kilo. Or you may write 6370 kilometer, which is nearly equal to 6400 kilometer. So, in some book it is written like that, 6400 kilometer. Okay, this is the radius of the earth, but in true sense 6.37 into 10 to the power 6, and g is 6.67 into 10 to the power minus 11. Let us see the value of earth, 9.8, 6. 40.57 divided by 6.67 into 10 to the power 12 plus 11 23 na 23. So, this into 9.8 divided by 6.67, it is 59.61 into 10 to the power 23 or 5.961 into 10 to the power 24. So, the range of 5.961 into 10 to the power 24. So, the kg. So, the mass of earth is in the range of 10 to the power 24 kg, 10 to the power 24 kg. Now, let us see the density of earth. Density of earth. Density of earth, rho is equal to mass of earth divided by volume of earth. Mass of earth me by volume of earth 4 by 3 pi re cube, right na. Now, 3 into me is 5.96 into 10 to the power 24 by 4 into 3.14, re is 6.37 into 10 to the power 6 whole cube. See, three into 5.96, 4 into 3.14 into 6.37, 6.37 into 6.37, 258.47 into 10 to the power 18, 24, 6 na 18, 6. Okay. Now, see, three into 5.96 divided by 4, 17.88 and 4 into 3.14 into 258.47, 3246.38 into 10 to the power 6. So, you may write it like that 17.88 divided by 3.246 into 10 to the power 3, right na. Then it is nothing but 17 point, let us see, let us see 17.88 divided by 3.246, it would be 5.50 into 10 to the power 3, right na, kg per meter cube. This is the density of the earth, that is 10 to the power 3 range, 5.50 into 10 to the power 3 kg per meter cube. So, thank you very much for listening and go through the assignment and notes thoroughly. On our next class, we will see the variation of acceleration due to gravity. So, if you have any doubts at any point, talk with me, but the thing is that go do all these assignments and notes, go through it properly, thoroughly. Okay. Once again, I am telling you that If you have any doubt on any topic, then directly talk with me. Thank you very much for listening me. Bye.